and the technology that you need to use these products is very simple. To be a hunter, you don't need very many complicated tools. You need a hunting weapon, and you can make a living as a Stone Age person, hunting animals. And all you need is rock to butcher, to make everything you need. As we lose the game, things get more complicated. Sure, we can replace hides with fabric, but that requires a very complex technology. Now we're talking, we've got to make looms, we've got to have ways to wash this fiber clothing. If we lose animal oil for lighting, now we've got to have a very complex technology to bring us electric light, which involves dams and transformers and power stations. Whereas what we had before, we didn't need very much technology. Okay, so if you can still imagine, stick with me, we're still in Pleistocene North America. I want to talk about a little bit about the old ecology. As you can imagine, if you take a bunch of very huge animals out of an ecosystem, it's going to change a lot. And I really like this quote up here. It sums it up pretty well. The flora that we think of as native is only about 14,000 years old. Elk, bison, they all come from Asia. And this used to be a land of elephants and horses and camels and hyenas. And what were they doing on the landscape? They were maintaining parkland. Is a simple way to put it. They were keeping a very open landscape, like the kind that you see here. So we've got widely spaced mature trees with grass growing in between. What happens when you lose those animals is that things start to get brushy and things start to get thick. And without large animals to browse that stuff back, we can become vulnerable to fire. In fact, fire becomes the dominant herbivore. And I read a great paper about how you can see in like sediments, during the decline of the megafauna, you get black mat starting to form because A, there was more organic matter just kind of building up and going acid like you do in a peat. And B, there was more burning, so you get charcoal too. And all these nutrients and carbon that used to cycle really tightly are suddenly just building up on the ground and even in the sediments. So here's the problem. Humans got here. It was a very familiar type of landscape. It was a savanna. It was a lot like where we came from in Africa and Central Asia. Without the megafauna, it's no longer savanna. It becomes a different kind of landscape. And people say, well, that happened a very long time ago. It's like talking about the dinosaurs. Well, no, it happened 14,000 years ago. That's only 140 lifetimes ago. I mean, you practically still smell them. They're still thawing out of ice up in Alaska. And other animals haven't had time to adapt. Plants have not had time to adapt. These are honey locust pods. There aren't any Native American animals that eat honey locust pods and disperse the seeds. We've still got trees that rely on megafauna to be spread. And the only reason species like honey locusts survive is because we're taking over from the megafauna and planting and dispersing. There's a great book on that called The Ghosts of Evolution. It talks about all kinds of species and ecosystems that need the megafauna back. So, one of the reasons the loss of the savanna was a problem is because of kind of a weird paradox, which is that the more biomass you have in an ecosystem, the smaller percentage of it will be food. And the reason that is because where plants concentrate the most calories, the most energy, the most nutrients is in their reproductive parts. It's kind of the bottleneck of their survival, and also in storage organs. So in a desert, you'll get plants investing more energy in seeds and in tubers and storage organs than in growth. And that's smart, because in a desert, a plant does not have a lot of competition. But in a jungle, the plants have competition. And they respond to that by investing way more of their energy into growth and dominance and wood, basically. They're storing their energy in wood instead of things like fruits and seeds and roots and tubers that we can eat. So there's kind of this weird paradox. Well, the more biomass there is in a system, the less there is to eat. And humans have solved that problem in a number of ways. And one of the first that we resorted to was burning. And I don't know that anybody else has made this argument, but I think that since the megafauna were gone, we became burners to preserve our habitat. And anthropogenic burning, is you may know, was a major tool of Native American groups up until contact. They're burning the forest in order to keep biomass low, in order to keep lots of green grass and fruits and root vegetables versus trees. In ecology, there's a kind of a catchphrase: the burden goes to the intervener. Intervene, guess what? You wipe out a species. If you wanted the functions of that species, you don't have to do it yourself. We've been doing this for a long time, everywhere. Australia, Europe, we've been burning. Much longer than we've been plowing. Here's another way to think of this. So you can see what I was talking about, how in a desert there's lots of energy being put into seeds and fruits. And the other thing that's interesting is that herbivore body size goes up with decreasing forage quality. The graph might help you make sense of this. So here it is. Animals that eat seeds are very small. The animals that eat the highest quality forage available in nature, nectar, are also very small. The bees. Big animals got big so they could utilize lower quality forage. If you're a big cow, you've got a lot of body space. You can hold low quality forage like rough grasses for a long time, and you're bigger and warmer, and you can use ruminant processes to digest your food. So that's why animals get big, so they can digest lower quality forage. And different types of ecosystems will give you different sized herbivores. So in a desert, about the biggest herbivore you've got is maybe a pigeon or a kangaroo rat. In a grassland, and grass is maybe a medium or low quality forage, you're going to have bigger animals, like bison, cattle, and the size of the herbivores influences which predators can live there. And in a grassland, you're going to have big pack hunting predators like wolves, hyenas, lions, and humans fit in this group. Whereas in a shrubland, which has a higher quality forage, you're going to have more medium-sized herbivores, rabbits and deer. And you're also going to have more medium-sized predators like cougars, which specialize in hunting things like rabbits and deer. And the great thing about this system is it's the only system that will support a large omnivore like ourselves. The bear is our counterpart. The bear's diet is pretty similar to our own. Pigs is too. Wild boar. This system is really cool because we have vegetable food to eat and we have meat. This system, not a lot to eat but meat. And in this system, there's not very much food at all. And we have to eat seeds, and we're not adapted to that. If you carry succession too far, this is that biomass paradox we talked about. All the energy of the plants is going into wood and growing really tall, and the only high energy forage available is in pine nuts, pine seeds. And these systems don't have a lot of room for big omnivores or big herbivores. They just have like jays, squirrels, and woodpeckers. And I think when we're designing our habitat, that's an important thing to think about. So, with all this in mind, I'd like to propose the savanna theory. And that's the idea that the savanna is our ideal habitat. And I think this is borne out by the fact that when people set out to create a habitat that is most aesthetically pleasing, we want to create a pleasant outdoor environment, we make a park. That's Manitou Park. And I read a really fascinating story about an anthropologist who went to the Methow Valley with an Indian woman who hadn't been to her homeland in a while. And she started crying. We can all imagine why she was crying. The land had changed a lot since she'd been pushed off. But what's interesting is she was crying because she said, we used to burn this land to make it open like a park, and now it's a jungle. And she used those words, like a park. And we even use the term park to describe some of our native ecosystems like the Ponderosa Parkland. And we integrate the Ponderosa Parkland, which is a natural ecosystem, into our artificial parks, in Manitou Park. What is a park? I got a few definitions for you. Close crop grass. We like that environment. It's easy to walk on. I think another reason we might like it is because when the grass is cropped short, that means there's going to be a big critter around there somewhere. And we spent so much time as hunters that that's a good sign for a good environment. Widely spaced mature trees. Those are important. We don't get a lot of food from most savanna trees, but they're important because they provide shade. I've read about a study in Oregon where they added trees to a pasture and the animals gained weight and did better because the cattle could regulate their own temperature better. The effects that the trees had on the climate allowed forage to mature at different times, so it kind of expanded the feed season for the cattle. Just had innumerable benefits. So trees are important. Habitat for us is not a treeless pasture. It's got to have trees. Some other elements of a parkland is we really like flowering shrubs. If you go to Manitou Park, you can see we planted lots of roses and dogwoods and hawthorns and crab apples. And that's because we've got a really strong relationship with the rose family and other plant families that make fruit for us to eat. And these plants are also a favorite browse by the big herbivores, and because of that, you'll tend to find these plants growing on steep slopes or on rock piles. They have a hard time surviving without a little bit of protection. And another thing we like in our parks is lots of pretty flowers. And a lot of the flowers we plant in our parks have bulbs, tulips, and like daffodils, and hyacinths, and lilies. A lot of these plants are edible themselves or have edible relatives. I think we look for these plants in a good environment. We like flowers. Sometimes there's food under there. And small mammals are kind of the backup. So hunter-gatherers, they were always pursuing larger animals. They didn't always catch them. Since smaller animals have smaller home ranges, they're easier to find. You can chase it into a burrow. It's kind of your backup plan. So sorry, honey, I didn't get the elk today. I brought home a marmot. We're going to be all right. And so this kind of represents a native park, what that might look like with ponderosa pine, serviceberries, and camas. But this is not the only way to do it. This could be an oak tree, like the Willamette Valley, or like the Black Hills. They have oak trees, and that would be great if this were an oak tree because it would provide edible mast for us and for small game, which we could also eat. And then there's so many more options for the flowering shrubs. Now, all kinds of fruits that we can plant. And we didn't have apples here, but we can kind of fill that role with newer kinds of fruit. And then there's all kinds of edible roots we can plant. And maybe we got more options than just elk and bison. We could use cattle. We could use camels or llamas or horses even. Parkland has many different forms that it could achieve, but as long as it's parkland, it's home.